In this video, we'll discuss different types of functions. But before we do, I just want to bring up what the inverse of a function is. So a function is a binary relation, and it does have an inverse. So if we have a function f, that's a binary relation on A cross B. So A is the domain, B is the codomain. The inverse of the function f is going to be a subset of the Cartesian product of the codomain B cross the domain A. And the inverse of the function is going to be the set of all ordered pairs BA such that the ordered pair AB is in the function. So once again, it's just flipping the ordered pairs in the function binary relation. So it's taking the point in the codomain and it's making it first and pairing it with the corresponding point in the domain. So let's look at a specific example as we have here. So we have the function f drawn, and in our function f we are mapping Zoe to CS104, Noah to Math 125, Jane to CS103, and Tommy to CS170. So now, given the binary relation for this function that we have drawn, we can give the inverse of this function f. And we take each ordered pair in the function and we flip it. So now we have the ordered pair CS104 Zoe, Math 125 Noah, CS103 Jane, and CS170 Tommy. And the key observation is that now the inverse of the function is a subset of the Cartesian product between B and A. Okay, now let's talk about specific types of functions. So one type of function is a one-to-one or an injective function. So in an injective function, you'll notice that every point in the codomain B has at most one arrow going in. And that means that for every element in the codomain B, there is at most one element in B such that f of A is equal to B. Now, if we want to show that a function is one-to-one, we have to show that if 2 points in the domain map to each other, this is only possible if they're actually the same point. So we can't have more than 1 point in the domain mapping to the same point in the codomain. And this is what is helpful to show that a function is not one-to-one. So we only need to give a counterexample in that case. So to show that a function is not injective, we just have to find 1 point in the codomain that has 2 distinct, so 2 different points in the domain mapping to it. So we'd have to find 2 distinct x and y such that their image is the same. Another useful observation with injective functions is that it's fine for some points in the codomain to have no elements in the domain mapping to them, but it is not fine to have any element in the codomain having more than one element in the domain mapping to it. Now let's contrast this with a surjective function. So a surjective or onto function is a function such that for every element in the codomain, there must be at least one element in the domain mapping to it. So that means every point in the codomain B must have at least one arrow going in. So now, in order to show that a function is surjective or onto, we need to show that for every point in the codomain, there exists a point in the domain mapping to it. To show that a function is not onto, we need only give a counterexample. So we just need to find one point B in the codomain that has no point in the domain mapping to it. And you'll notice that in contrast to a one-to-one function, for a surjective or an onto function, it's totally fine to have 2 points in the domain mapping to the same point in the codomain. So you'll notice that we have both Jane and Tommy mapping to 170, and that's totally fine. The key point is that in this picture, every course has to have at least one student mapping to. So that's what we mean by a surjective or onto function, that every point in the codomain has to have at least one arrow going into it. Now, a bijection is a function that is one-to-one and onto. And what that means is that all elements in the codomain must have exactly one element in the domain mapping to it. So that means there's exactly one arrow coming out of each element in A and exactly one arrow going into each element in B. So that's what it means for there to be a bijection. And we're going to see examples of how to use these and consider these definitions and to tell what type of function is in the next set of videos.